So today we have the privilege of hearing from Mark Trushkowsky, and he is going to talk about fractional reasoning across math levels. So I will turn it over to you, Mark.
Thank you, Lindsay. And good morning, everybody, and welcome. The pleasure is all mine. Like Lindsay said, and like they say in the airlines, you had your choice of really amazing workshops this morning. And so thank you for joining us here. So I'm gonna, introduce a couple of ideas that'll take us through the session. But as I'm doing so, I'm just curious in the chat, I'm curious to hear like why you chose this workshop. If there's some reason that brought you here or some question you have, please let us know in the chat. But like Lindsay said, my name is Mark Trushkowsky. I work with the City University of New York, a CUNY adult literacy program in New York City, and I moved to Minneapolis 2 years ago. So I'm newly adjusting to my life in this beautiful state. So I'm going to start with a fact, a truth that will not surprise any of us, but time is no ABE teacher's friend. We teach in one-room schoolhouses and mixed-level classes, and we have fractions to deal with. And I think, one of the things as I was starting to build this workshop and think about what ideas were important to me and kind of what I wanted to learn from the process, is I was thinking back to, my first years of teaching when I was starting out and I wasn't quite sure what to do. I was an ELA specialist and a history specialist. And when I first started teaching math 20 years ago, I was teaching from the workbook. That was like the first place that I started. And the workbook is sequenced in the sequence that I'm sure you are all familiar with. And I something that I strove to do then and have been trying to do ever since is, what we don't want to do is spend months teaching fractions, because what would happen is I would start off those kind of beginning, those number things, those things that were decided to be like basic and foundational. And it would take so long, we would spend months on fractions, and then we would get to complex content only at the very end of the semester with my students. And I realized I wasn't serving them well, I was frustrating them. And especially when there's so much rich work that students can do in functions and in algebra and in geometry without mastering fractions first. But at the same time, fractions are really important and they're challenging, always, but especially when there's that time pressure. We have students who are in so many different levels. It's very easy to slip into too many procedures and not enough conceptual understanding, and the end result of that being that students get stranded. And so kind of the question that started me off is how can we continue or even begin to develop our students' conceptual understanding of fractions while we're teaching more advanced content, or while we're teaching any content for that matter, but specifically while we're teaching more advanced AB and HSE content. I'm just going to read that quote. I know it's there, and I typically don't read text straight from a slide, but I really enjoyed when we add or subtract fractions, we have to find a common denominator, but not when we multiply or divide. And once we get a common denominator, we add or subtract the numerators, but not the denominators, despite the fact that when we multiply both the numerators and the denominators. And when we divide neither the numerators nor the denominators. I know it's very early to have said a thing like that, but I feel like that's what kicks around in students' head. That's when there's only procedures, there are so many, and it's really, really difficult for our students. And so here's our agenda. Here's our hope. It's action-packed, but I believe in us. Fractional reasoning. We're going to start off with a big idea. There are lots of big ideas, lots of core concepts in fractional reasoning, but I picked one, and we're not going to spend a lot of time in this area, but we'll take a look at one big idea that I think is helpful for kind of crossing into other content. We're going to look at some sample TABE questions, and they're TABE. Well, I'll talk more about that later. We're going to look at some sample TABE questions just to get a sense of a quick sense of the scope of some things that students need to be able to do on assessments with fractions. We're going to look at 2 instructional routines, and those instructional routines are fraction-based. And the idea behind them is, what are things we can do in an HSE class that won't feel like we're going backwards, that they won't feel like, oh, but we should be doing this other stuff, that will feel challenging enough for students, while still helping them develop the conceptual knowledge that they may or may not have. And we're going to look at some fractional reasoning and higher math level content, just a little bit, because there's a lot in the middle section. But I do want to start taking a couple of steps in that direction. And so the things that you're looking at now, those 4 sections, are going to be an overview. And what my goal is to get us as much time as possible, because I really want to carve out a good chunk of time for you to play with the instruction routines and those TABE questions and some of the higher level math content. And we'll be doing that in breakout groups. So you'll get to do some math, and you'll have a lot of choice in the math that you do while working on that. So that's our agenda for the day. I hope that sounds good. So fractional reasoning, what's a big idea? Just a big idea, like I said before. But I wanted to pick of something that was versatile. And my hope is that, maybe you'll see connections with the activities and the problems that we're going to look at, and this big idea that we're going to look at now. And also my hope is that you'll see connections with what you're working on with your students, because that's kind of a theme that I've been kind of pushing myself in, and I offer as a frame, is just thinking about all the different, whatever the content is that we're teaching, what are some ways that we can get some fractions into the discussion. So here's our big idea. I picked this particular big idea, but like I said, because I feel like it's cross-cutting, but it's also incredibly visual. And so for the amount of time that we have, I thought that was good, but also, and more importantly, in terms of engaging students in this idea. Here are 2 images for thinking about fractions. So our first is partitioning, which here's an area model of partitioning. And the idea being is we have a whole, and 1/8 is the amount we get by taking that whole and dividing it into 8 equal parts, and then taking one of those parts, right? So taking a whole and breaking it up into 8 parts, and then one of those parts. So that's an area model. The other kind of model, another way that can be helpful to think about this, especially as we're looking for opportunities to bring this idea into other content areas, is a set model, right? Where we have some whole here, there's 24 dots. We take we take that set and break it into 8 equal parts, and then we take one of those parts. Okay, so that's partitioning. Oh, thank you. I just saw in the chat someone says they love math. I love you and math, Shelley. Thank you for sharing that. So we have partitioning, and then we have iterating. Iterating is kind of working the reverse. So we have 1/8, and we iterate that amount such that 8 copies, we iterate it 8 times to make a whole. So we start with 1/8, we reproduce that, we iterate that 8 times, and we have the whole. And again, the same works with the area model and the set model. We start with that 1/8, and then we iterate it out to the whole. Okay, that's it. Very basic, very visual, and let that sit in the air, and let's move ahead. So fractional reasoning, TABE your wild mind. So for this next activity, we're going to look at some TABE style math questions. So these are not actual questions from the TABE, because it gets complicated at a state conference if you start sharing actual questions from an assessment that students have to take. But they're TABE style questions that I've written, and I've changed the numbers and the situations, but I've kept the style and the general structure of the problems intact. And in true like nerdy confession, my favorite thing about kind of rewriting questions or writing any kind of TABE or task or HSE or high set or any kind of problem like that is focusing on the distractors, which are those wrong answers that are compelling, that have students choosing them. So I tried my best to kind of mirror what the distractors on the actual TABE are, the student misconceptions that they're targeting. So like I said, I changed the numbers, but I didn't change the types of fractions. And what I mean by that, every once in a while on the TABE, you'll see something like, 3/17, but far more common are benchmark fractions or benchmark adjacent fractions like the ones that you're about to see. And so we'll talk about that term benchmark if that's unfamiliar, but just to kind of, I want you to be mindful of the kinds of fractions we see or the kinds of fractions that are on the table, which many of you might have already looked at. And so we're looking, I just wanted to say, we're looking at TABE questions as opposed to standards because they're more visual. I felt like they were easier to talk about in a short period of time. And frankly, as much as I love the CCRS, it's a little bit early to be looking at them in depth. But in the share folder, what I did create is a document that looks at, it isolated all of the fraction standards from the CCRS, both across the levels, but then also where fractions show up in other content areas, like in geometry and geometric measurement and data, expressions, equations, statistics, probability, ratio, proportion, reasoning, number system. It's all over the place. Last thing I want to say about the TABE, we're going to look at the level E, M, and D. And so just to kind of break down, just to give you a quick picture, you let me know in the chat what your takeaways from these numbers are. But out of each TABE has 40 math questions. There are 18 questions on level E that deal with fractions. There are 17 questions on level M that deal with fractions, and there are 9 on the level D forms. And I'm talking about both 11 and 12. So that's 44 out of 120 questions deal with fractions. That is a lot. Okay, so I also, because just to let you know, the goal right now is not to work on these problems. When we have the playtime, you will have the option to choose if you'd like to work on these problems a little bit. But our goal right now is not to solve them. But we're going to think about the things that we can do with fractions. And we're looking for like coherent big ideas that we can leverage in our classes with our students. And so it's like I said, it's fairly early on a Friday morning. And so I thought we would look at these problems as a kind of a game. So I'm going to put a problem up, maybe every 5 or 10 seconds or so, I'm going to put up a new problem. There are 8 in total. And what I'd like you to do is decide, you can jot it down on a piece of paper or just kind of know for yourself. Decide whether or not it comes from the level E, the level M, or the level D. And if anyone's unfamiliar with the TABE, the E is the easier one, the M is middle level, and D is difficult. I'm not sure if that's actually what those letters stand for, but that's how it plays. And then the A is the advanced. Okay, thumbs up, everybody ready? Get your guessing. And here we go. So what form, easy, medium, or difficult? What form do you think that comes from? If you want to be bold, you can put it in the chat, but you don't need to. I'm not sure if you can see that. That's 22 4/5. I'm not sure if that's big enough. I apologize for that. Okay, so that's all 8. I'm going to give you about 15. I'm going to give you about 10 more seconds just to kind of think about what form you think that is, and then I'll share what form they're on. Okay. There we go. So we're not going to spend a lot more time on this, but I'm curious, and we're a small enough group that please folks should feel free to unmute themselves, but how did you do? Were there any surprises? Did people feel like you pretty much got what level each one was at? Let me start, maybe let me ask it this way. Did anyone get them all correct? Unmute yourself and let your light shine. Okay, good. So no, so I'm curious, were there any surprises? Was there one that was really surprising? Like maybe you said it was an E and it was an M, or you said it was a D and it was an E. Anyone? Oh, some of the problems are fuzzy to read. I'm sorry about that, Shelley. Elizabeth said in the chat, I thought M for the wall or window problem and D for the miles run problem. So Elizabeth, the wall and window problem, I actually would give you credit for the M, because using area that has one of the sides, one of the measurements of the side is a fraction, is actually on the M as well. So I would give you full credit for that. D for the miles run. Yeah, I also, that seemed much harder to me than I also thought that should be on the D. I assume the upper right was the M, right? Okay. Okay. Cool. Well, thank you very much. So we have some ideas. And now let's jump into some teaching stuff, some stuff that we can do. And we're going to look at, like I said, 2 instructional routines. And so the idea, behind these are things that I'm using or I'm thinking about and I'm trying out with students to figure out, like, what are things we can do that are going to help build students' conceptual understanding of fractions when they're higher level students, when they can be very reluctant, so they don't want to do fractions. They feel like it's going back. They think they only want the hard stuff. Though fractions, as we know, is also very difficult, but the stuff that feels hard, looks hard. So the first one, and let me know in the chat if this is something you're familiar with, but the first one is a routine called Fraction Talks. And it's also a very handy website, which has a large collection of these. So let's take a look at the routine. And so in the chat, let's take about 30 seconds and just share, looking at that image, what do you notice? What are some things you notice when you look at that image? Yellow and orange. Okay, Lindsay sees triangles. Shelley, she sees shapes, colors, fractions. Shelley, can you talk a little bit what shapes you see, what fractions you see? Elizabeth and Michelle also seeing triangles and squares. We see a parallelogram. Halves and wholes. Nice. Aren't those called tangrams? These are actually, I'm not sure if these are called tangrams. I know that tangrams are shapes, but I think it's a particular combination of shapes. These are certainly manipulatives, but I'm not sure. If anyone else can answer Andrew's. Okay, so Shelley is agreeing these are not tangent. They're very similar because they're shapes that can be manipulated, but we will be looking at some other shapes that are tangrams. So the idea that they're fractions here, and specific fractions I've seen halves, wholes, which is a fraction, and 1/8 is a fraction. I'm curious, take a moment and think about this question, but please don't put it in the chat yet. But think about what fraction of the area of this figure is yellow. So we have this larger square here. What fraction of the area is yellow? We're going to do a waterfall chat. So I'm going to give you a little bit of time to think about that, and then we'll all put our answers in, and then we'll hit enter at the same time. Shelley's answer slipped out, but that's okay. All right, so why don't you hit enter now? What fraction? So I see, okay, I'm seeing some consensus 1/2. Can I have someone unmute and tell us, how do you know? How do you know that it's 1/2? Like if there was another yellow square here, I would see the half easier, but how can we see the half?
Well, if you take the upper right quadrant, or whatever you want to call it, and you cut the parallelogram in half, and you rotate that yellow triangle down into the bottom right quadrant, it would make another square, and then you could slide the square over to actually show it's a perfect half.
So you're saying if I cut it in half right here?
Yep.
Okay, and then drop that triangle down. Okay, then we would have 2 yellow squares and 2 orange squares. Nice.
Yep.
There are a lot of other halves. Did anybody see it in a different way? How else do we know it's a half?
I saw it sort of the opposite way of Shelley. I would have sliced the parallelogram the same way, but then moved that lower triangle up to the top half of the orange square.
Mm-hmm. Okay, so then the whole top would be yellow. Anyone have a third way?
Just noticing that the 2 red triangles on the right quadrants would make a whole, or square, and that would be half of the whole square. So therefore, the yellow has to be the other half.
Mm-hmm. Okay. Cool. And along those lines, like some people saw triangles before, you might split the whole thing into triangles, and 1, 2, 3, 4 triangles, and then 1, 2, 3, 4 triangles. There's lots of other ways to do it. But so the particular image that I looked at from Fraction Talks is I thought it would be a good one to start with because it's very accessible. They get far more complicated, and we're going to look at, in your group time, you're going to look at a couple of more complicated ones. But we're going to move on, and I want to, especially because someone mentioned, oh, wait, let me see, Susan said, you can cut the yellow square in half and use the pieces to cut the red. So you can cut this one in half. Oh, see, that's how I like to see halves, like this vertical section. So if we cut this one in half here, we can slide it over and slide it over. Awesome, thank you. So let's look at one more image from the Fraction Talk website. So these are tangrams, I believe. Someone should correct me if they're not, but this particular set of shapes, because there's fractional relationships between them. So I'm going to give you 15 seconds. In the chat for this one, what do you notice? We have some different shapes, different configuration. What do you notice about this one? Pattern blocks, yes, these are pattern blocks. Tangrams are the thin ones. Oh, symmetry, Shelley sees, nice. What else do you see? What else do you notice? The blue diamonds fit inside the yellow hexagons. So first of all, we're seeing diamonds and hexagons. 3 blue equal 1 yellow, interesting. That's something certainly we would pursue, and I would make you justify or share more of what you're seeing. But I want to move on, but I do want to give, I want to ask one question, because for the Fraction Talk website, it's not just images, but they're questions that you can ask. And so I'm going to put one question out there. There are many, and you'll have some resources for knowing having access to different questions. But I don't want you to actually answer this one right now. I'm only going to give you 5 seconds, but just take a guess, just from your gut. What fraction of the area of that figure is blue, the entire figure? This one. 5, 4, 3, 2, 1. First guess? Any guesses? 2 8s, 2 9s. Keep them coming. I'm going to move to the next image, but keep those coming. There's a different question, 1/3. I love it. So just another question. We're not gonna go into it, but I want to start, because obviously shapes have come out, the names of shapes have come out, symmetry came out. We were talking about area. If the area of one of the blue rhombi, which is what I'm calling these diamonds, is 4 square inches, what's the area of the entire figure? What's the area if the rhombi is 5 square inches? What if it's n square inches? Just there's lots of different directions that we could take a question like this. But we're going to hold that because I'm trying to get you to your free time, your play time. So Fraction Talks is one instruction routine that I found, it's fun. They're interesting, they're hard, they can be really challenging. There's lots of different ways to see and come up with the answers. There's so many different kinds of questions. Students can start asking their own questions. So it's just a different way to engage, I found, with some interesting fraction concepts. And also, because it's so observational based and conversational based, it kind of turns our mixed level classrooms into a strength, which, I'm always looking for opportunities to do that. So the second instruction routine is the website Open Middle. And can people in the chat, just let me know, or you can even just give me a thumbs up on your, through Zoom, just if that's a familiar site to folks, but I'm just going to kind of describe it a little bit. But it's been around for a while. The 5-second elevator speech is that it's a website with hundreds of challenging problems worth solving. The slightly longer elevator pitch is that it's called Open Middle, and it gets its idea from having a closed beginning. So like students all start with the same initial problem, and it has a closed end, meaning at least when they started, it had a closed end, meaning they all end up with the same answer. Over time, they've included more problems that have multiple answers. But the middle is open, meaning that there are multiple ways to approach it and to solve each of the problems. And other things that I like about all of the problems that are there in Open Middle are, they generally have multiple ways of solving them, as opposed to, using a problem where you solve it with a specific method. There aren't really methods. There's certainly strategies, and there are things that can help us, but there's not a method or a strategy. There's nothing like, oh, how do I solve a problem like this? Which is something that I'm trying to break my students of when it comes to fractions. They also involve optimization, so that, it's easy to get an answer, but if you're looking for like the biggest answer of something, you can always say, is that the best answer? Is that the biggest answer? Is there an answer that's even better? And the other thing I like about them is they appear super simple and very procedural, but they turn out to be much more challenging and much more complex when you start to solve it. And again, you guys will have some time to solve it. And so I just wanted to give you a couple of examples. So like here, often it's about the fraction ones that I pulled are often about using digits 1 through 9. So this first one, use the digits 1 through 9 each once to make this a true statement. So something and a fraction plus something, a whole and a fraction equals something and a fraction. And so this one is saying to use the numbers 1 through 9 each once. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 blanks. For the other ones, use digits 1 through 9, fill in the blanks to make a whole number sum, and use each digit only once. You don't have to use them all because obviously there are not enough blanks here. But you can like if you put a 9 here, you can't put a 9 anywhere else. And this one has the extra bonus of can you make the number 1, the number 2, the number 3, all the way up through 9. This is just to kind of go back. This is an example of what I meant by like that optimization kind of a problem, because here we're trying to make the largest sum. So students can come up with one and another student can come up with another, and you can have them compare. And is that the most? And how do you know that's the biggest number you can make? So there's all kind of room for adjusting it based on students. So again, this is just an overview. You're going to have lots of time to work on these problems. I say lots of times, but you'll have as much time as I can get you. But I want to fill in one last piece, which is how do we incorporate fractions into higher level math content? And this is the thing. Hopefully, at the end, you all will add your ideas to this. This is a small piece of it, but just things that I wanted to share that I've been trying with students. So the first thing are function machines. So if functions is something that you're teaching, function machines for me are great for incorporating all kinds of content into function work. And so the way a function machine works, if you're unfamiliar, is it's basically the way the machine works is there's a number, you put it in, you do something to that number, and you get another number out. And so we can use the chart. So here we put a 6 1/4. I'm sorry if that's too blurry, but 6 1/4, you put it in, we do something to it, and we get it out. So obviously we don't know what to do from that one, but for the next one, we know if we put 1 1/2 in, we do something to it, a 3 3/4 will come out. Okay, so we can start thinking about, well, what are different ways to, what are different things we can do to 1 1/2 to get to 3 3/4? And when we take a 10 3/4 and we put it in, we do something to it, we get a 13 out. So now we have 2 numbers that we put in and we know what gets out. And so it's about students looking for patterns. Of trial and error comes in a lot. It's really important. This is a really important concept in linear functions. And it's a very easy way, not easy in that, easy from the perspective of a teacher. It's very easy to incorporate into, here's another function table. Again, you'll get to play with these if you so choose in our playtime. And a teacher's best friend to me is the blank function machine, where we can weave in any content that we want. I use it for percents, all kinds of things. Okay, so one other, this is the last thing that I kind of wanted to just put out into our overview before we can now push deeper into all of this stuff. But another interesting situation, interesting opportunity to talk about fractions is negative exponents. And so this activity right here is taken from a set of materials that I've worked on, but it's basically a notice wonder. And so students kind of are looking for patterns, and you'll have an opportunity. If you know how to fill this out, then you can look at it as a teacher. But if you don't, it's a really fun, interesting, challenging way for students to kind of, for learners to kind of look at this, try to find some patterns and fill in the rest of the chart. And specifically the focus is, what happens with negative exponents, kind of what's changing in each of these columns. Okay. So that, I'm surprised I'm not out of breath. That whole thing was, I wanted to get you as much time as I could, and I think I did okay. Let's see, 1, 2, 3, 4, 5, 6. So I think we'll break into 2 groups of 3. And so I just want to kind of describe what's going to happen. So in your breakout rooms, you get to choose how you're going to spend your time. And so we're going to give you a Jamboard link. And that Jamboard has some examples of the instructional routines. There's a couple of math talks in there, excuse me, fraction talks. There are those open middle problems that we looked at. And then there's some fractions and other content areas. So there's some function machines. There's that negative exponent table that we were just looking at. And then there are the TABE style questions if you were hankering to work on them a little bit, but also if you do those, I would kind of encourage you to kind of think about what are the things that you're doing and how could they connect to other math content, or also what other math content are you seeing in the problems that are there. I want to give you just a quick overview. I know at this point we're all pretty familiar with, with a lot of tech things, but I never assume, and we're all still learning. I'm still learning. So when you get into your Jamboard, there's 20 slides. So probably the easiest way, I would suggest you kind of skim them all. So if you go to the top, there's this little down arrow. That'll give you you'll be able to see all of the frames. And so you can kind of just see, oh, that looks like something I'd like to do. There's that shape of the hexagons. There's some coloring in there. For these are from the open middle. These Post-its can move around, so you can kind of trial and error them. You don't have to do this, obviously we're unable to be together, but open middle, I've done them with students on paper and pen and pencil, that works fine too. And I wanted to try to be very conscious of that, not do stuff that everything can be done face to face. There's a couple of function machines for you to play around with. There's some blank ones for you guys to play around with. There's that table, and then there's some blank, and then there's the table. So I just recommend looking through and deciding. So, as a group, you can decide to kind of work on your own things, or you can spend together. I mean, I feel like we don't have the resource of each other, and you're all each other's strongest resource. But if you do work on your own, because that's, it's for you guys to decide, I would encourage you, and I'll give you kind of a heads up when we only have like 5 minutes, just to kind of check in and kind of report out to each other what you've done before we come back together. But other than that, we'll put you in your room. So I'll stop for a second and see if there are any questions. I know that was a lot to take in, but any questions on either the breakout rooms or anything that I've said so far? What was the source of the quote that you cited on the first slide? It's from an article. I forget the exact name of the article, but the article is on the bottom. You know what I can do? I didn't do it, but I will. I can put the article itself in the participant folder, so you'll be able to read it. Thank you for that question, Andrew. No problem. Any other questions? All right, then Lindsay, or I forgot who's setting the breakout, but
yep,
I think we can.
I have it set. So there will be 2 breakout rooms. These are not going to be recorded, so feel free to unmute and talk. And then I am putting 2 Jamboards in the chat. I just put those in the chat. So if you go to breakout room 1, as you're going, it should say room 1. You can click on the first one, and if it's group 2, you can click on the second one. You can share your screen. So if someone is super savvy with Jamboard and you want to share your screen and do it that way, that's an option as well. So I will pause the recording and
welcome back, everybody. I thank you for letting me crash your breakouts. Obviously, there's a lot more there than you'd ever be able to do in one breakout, but you have those forever, and you have the resources that I pulled them from are also available. And I'll re-put the links again at the end. And we're coming up on our time, but I just kind of wanted to give us, I'd like to hear, I heard some great conversations, and I'd like to continue to hear conversations, and I just wanted to open it up. We're a small enough group, so just, unmute yourselves, and I'd love to hear any takeaways or aha moments or questions, anything that came up while you were working in your group. You can unmute yourself. The chat works too, but we're small. It's nice to hear your voices. So it was nice in the breakout rooms to hear you talk. Anyone have anything you'd like to share?
There is a question from Jennifer. Is there a way to save the Google document into a smartboard file?
So the Jamboard, I'm actually not sure that you're able to put it into to do that with those images. Like it's Google Jamboard doesn't have as much functionality as some of the other Google tools in terms of that and saving and moving it, but all of the images that are there came from other resources. Like all I did was take the image from there and put it in the Jamboard. So like, for example, if you want to do a fraction talk, you can go to the Fraction Talk website and there are hundreds of different, like we really just scratched the surface. There's a lot more there. And so you can share the image that way. Same thing with Open Middle. Thing about the Open Middle, I didn't want anybody to go to the site, but they actually have answers available. They actually have a hint first, like you can click on a hint or you can click on an answer. But you can just go to those websites. The function machines are from a CUNY document that I put the link to in the slides. It was at the bottom of the slide and it'll be in the PowerPoint slides when you get them. But Jennifer, does that answer, is that kind of, will one of those solutions work for how you're thinking of you might use it?
Yeah, that would work.
Can I ask which ones you were thinking of using?
I'm gonna have to just get the pictures and put them into a smartboard document. My smartboard isn't connected to the internet, so I have to like make the document prior and then do it, if that makes sense.
Yeah, absolutely. It's really handy. Both Open Middle and the Fraction Talks are very easy to copy and save the image file. So then you can just put it in a document and email it to yourself or have it, have it on a zip drive or something like that.
Perfect. Thank you very much.
You're welcome. Any other takeaways, ahas? Did anyone see any other opportunities for weaving fractions into content areas, either something you thought of or something you're already doing? Because I feel like I'm just scratching the surface with all of this. So what did I miss? I'd love to hear if there's anybody has any final words. All right, well, to be respectful of y'all's time, I'm just going to leave it here. That's my name and my contact. I'd love to hear about anything you do or answer any questions that come up hopefully you'll bring some of this, something to your class, something here resonated with what you came looking for. And those are the resources, the fractiontalks.com, openmiddle.com, collectednewyork.org is if you're not familiar, is a website I maintain through my work at CUNY that has not just math, but all materials for adult education teachers, and it's all reviewed and used by adult ed teachers, and then they come and share it. But specifically the exponent thing and the function machines, you can find them all there. And then in my last 10 seconds, the Adult Numeracy Network is the national organization for adult numeracy teachers like us. Even if you're not just a math teacher, anyone who's interested in teaching math will find a home and a community at the Adult Numeracy Network. And so if you're interested in that, if any of that sounds interesting, that's the website right there. Other than that, thank you all so much for your participation and for coming this Friday morning. It was great working with you, and enjoy the rest of the conference.